Hi class, this is very first video to respond to the new curriculum IBHL. We call it analytics approaching. So I reintroduce you the one unit circle with the third definition of trigonometry. So when you put like this, mean the radius equal 1. So now every point, the point moving from here to here. In the past, we learned about the angle, right? So in standard position, the angle go like this. Let's say this on 60 degrees, the angle. But now we not consider angle anymore. So we call the real number, the distance from here to here. Let's say distance t, the length t. So now in the past, we have the angle here, also t in radian. So the reason is they're the same because the one unit circle by definition of the radian. So now we define this way. The point moving along the curve here, so we call the initial point, starting from here. And the point moving up there, so we call the terminal point. So the line here, t, is we call the real number. And we call it the third definition, the trigonometry of the real number, not the angle. So go this way. So we call psi of t in the past, psi t means this one, but now this t here is the real number. Okay, psi of t equal y. The reason is if you think in the past here, this one should be y, this one 1, right? So psi of t equal y over 1, which is y. So now t here is psi of t equal y. Okay, and cosine of t equal h, and tangent of t equal y over h, the same with the past, but now you keep your mind that t here is the real number. So and so on, we have cotangent of t equal h over y, and secant of t equal 1 over h, and cosecant of t equal 1 over y. So we have 6 functions. Now the next question is, why we need the third definition trigonometric function? That is my question. So let me go back into the very first lesson, how to graph the sine, the function sine, right? So we plot the point. We plot this one is 30 degrees. Okay, so we remember we give the whole set of the point like the angle theta. This one y, theta equals 0, y equals 0, theta equals 30 degrees. Y equal 1/2, the theta equals 60 degrees, y equals root 3 over 2, and so on and so forth. We already mastered that. So let me plot the point to see what happened. So this one 1 here, this one negative 1 here. So the 30 degrees, sine 30 degrees equal 1/2 right there, right? 30 1/2. So sine 60 degrees equal root of 3 over 2 is about 0.85. And sine of 90 degrees, which is right here, equal 1. So now we connect the function sine like this. So can you see what's wrong with this? What's wrong with this? So the point here should be 90 and 1 degree. So now, what's wrong with this? This is so wrong. Why? Because this, we put the graph into the, we call the Cartesian plan, invented like more than 200 years ago by Descartes, the French mathematician. So every point in his plan has to be the real number. So for example, if I count 1, 2, 3, 4, 1, 2, 3. So the point here, 4 and 3. Number 4 here and number 3 here are the same value. So from here to here is 4 units, from here to here 3 units. So they have the same value, the same character. So therefore this one's so wrong. So this one and this one not the same value. For example, if you want to find the slope between 2 points, right, you connect the slope here, and you set the slope equal rise over run. So the slope equal 1 over 90. That's so wrong, right? So the slope here look like more than 1. So less than 1. Here you have 1 over 90. That's the first wrong. Okay, next one. So now we go to the second definition. So this we change into pi over 6. Okay, change to pi over 3. Now the point is equivalent now. Pi over 2 is about 1.5. So the point here should be pi over 2, 1. Okay, so pi over 2, this one real number, and this one, the value is equivalent value. So pi over 2 is about 1.5, and this one 1. So therefore, if you want to find the slope, this one equal 1 over 1 pi over 2, which is 2 over pi, which is about 0.6 or something, right? So this one good, but still not good. The number is equivalent in the value, but the idea, the meaning of this one different from this one. Because pi over 2, for example, I put here pi over 6 here, and this one pi over 6 here. So now sine of pi over 6, sine pi over 6 here equal 1/2, right? And sine pi over 3 equal √3 over 2. But this on the angle, this on number, completely different meaning. So even though this one close, but still not legitimate. So that's why we introduce you this one here. It introduce you the third definition of trigonometric function, we call the circular function, and explain why we need all these things. Okay. Yeah. Okay, now I use the third definition to show you. I turn everything, the angle, into the length, the real number. And you see what happened here. Let's start over again. So this is one in each circle. So any point x and y here, so the value y is the sine of function. Sine of this, in the part, this angle now, sine of this line here, and y is the sine of this line here, and y here, the line of this one here, and the t equal the distance. So let me start the first one. So look like this. You have t here, sine of t here. Okay, when t equals 0, sine t equals 0, right? So the point right here, okay, t. Now I change this one into t. Okay, when t equals 0, sine 0, how about pi over 6? So t equals pi over 6, in the past you have 30 degrees, right? Sine equals 1/2, so the point here. Now pi over 6 here, not angle. Here is the line from here to here. That's pi over 6. So pi over 6, here is the angle. But new definition here, pi over 6 is this line here. So I mark it and I flip onto here. So this becomes that one here. Pi over 6 represented by the length. And y equal 1/2. So where 1/2 here, this one y 1/2, I match this point into pi over 6 and have the second point. Okay, that value of y equal 1/2 when pi over 6. So now the next one, I put pi over 3, y equal √3 over 2. So pi over 3 in the past here look like 60 degrees, right? So now pi over 3 equals the line of this one. So I mark the line of this one, I mark into here. So I mark pi over 3. So pi over 3 is the real number now, not angle, the line from here to here. And the value of sine of pi over 3, the distance from here to here. Okay, pi over 3, the distance y equal this much. So I mark this one into here and I connect the other point and have the graph of sine like this. Next one, when pi equal t equal pi over 2. So the line pi over 2 here, I mark this line, boom, right here. So this one we have pi over 2, and the value of sine pi over 2 equal 1 because the sine is y and cosine is x. So 1 right here, I move 1 right here. So I have the next point, then graph like this. Next one, so now I consider 2 pi over 3, which is 120 degrees, right? So t equal 2 pi over 3 means the distance all the way from here to here. I stretch out mark right here, so I have pi over 3, over 2, I'm sorry, pi over 2 right here. So now the value of 2 pi over 3, the value of 2 pi over 3 is the length from here to here. I mark in there, and the value here, I go like this. The value of y of this line here equal this much, so I move all the way from here to here, and I get a point here. So I connect from here to here. You see the symmetrical here, right? So the point is symmetrical for that one. Sine of 60 degrees equals sine of 120 degrees. The next one, the next point here, which is 5 pi over 6, all the way from here to here, the angle 5 over 6, but the line here also 5 over 6. So I mark this line, mark into here, and you have 5 pi over 6, and the value here equal 1/2, the same thing with the sine of pi over 6. So I move all the way from here to here, the point here, and then connect them. So let's do a few more points. So when this on half the circle, which is pi, right? So the value of y equals 0. So pi right here. So half the circle is pi right here. So then I go over here. So this one pi and 0. So that makes it half of the period of pi. Now take a look at this. When pi become 5 pi over 7 pi over 6, all the way from here to here is 7 pi over 6.